Morning, let's be welcome to another short and sweet lesson on how to do conversions. We have prefixes, and then we're going to be using the prefixes and conversions factors such as 2.5 centimeters per inch or 2.2 pounds for 1 kilogram of matter to figure out what the mass of our minion, Kevin T. Minion, is in meters, centimeters, nanometers, and kilograms and tons, because we have to use the metric system. We don't use the imperial system here in the United States anymore, even though everybody thinks we do. If you look at any kind of thing such as this, it says 16.9 fluid ounces. The 500 milliliters is actually the real measurement, or 1.05 pints, but the 500 is the number we use. The rest is there for customer convenience. Since you're going to be having to do this in science all the time, let's figure out how we're going to do this. To begin with, when you do a conversion, you put your beginning number here, set up the brackets, and you want to put the conversion factor in such a way that the unit you're getting rid of is on the bottom, the unit one it keeps on the top, and you get the answer that way. So when we look at this, we can say, okay, how do I do that? Well, see how well this shows up. .2 pounds, is that appearing real well? Okay, is equal to 1 kilogram. If I divide this by kilograms, I can write it as this. This becomes 1. I could also have gone the other way and went 2.2 lbs equals 1 kilogram. Divided this by 2.2 pounds and gotten 2.2 pounds down here. So I end up with this, and this is a conversion factor. They're both equal to 1 over 1. And I can flip these back and forth. Now what you do when you want to do your conversions is you come along and you say, okay, what's my starting number? Well, my starting number is 30.0 pounds. I want the version of this that goes with pounds, which is 2.2 on the bottom. So I say 2.2 pounds here, 1 kilogram here, equals, this would give me 30.0 kg, and then I'd have lbs divided by lbs. These go bye-bye, leaving me this divided by 2.2. So all of this becomes the new answer. Now, I don't know how well you do this in your head. I don't. So we're going to try this with a calculator. First, let's check to see what mode it is. Right now it's in floating mode, floating decimal. At some point we're going to go to our friend scientific notation. But 30 divided by 2.2 equals 13.63. I'm going to write 13.6 kg. You notice I lost the 363636 because I only had 3 digits here. 3 digits here, 3 digits there as far as significant figures. So for my first answer, I can write 13.6 kg. Of course, I'm supposed to show my work. See attached. Now everything else seems to be in grams and in the tons. Now I can then look and say, okay, how do I do grams? Well, a gram is, there are 1,000 grams in a kilogram. How do I know this? When I go over here, kilo, 1,000 times 10 to the 3. So when I put a kilo in front of something, it says I'm taking that number by 1,000. So there are 1,000 grams is in 1 kilogram. This gives me the conversion factors of 1 kg over 1,000 grams, or 1,000 grams over 1 kg. Now when I go to do the problem, I need to say, okay, which way do I need to do it? Well, my starting information is 13.6 kg. I have a kg here, I need the kg down here. That puts the 1,000 grams up here, which means I end up with 13.6 times 1,000 kg grams, or 13,600 grams. Now I'm going to need this in scientific notation. Now I can count the decimals, 1, 2, 3, 4, or 13.6 times 1,000. If I go second, that button there says float, push it over, get scientific notation, and now it says 1.36 times 10 to the 4th grams. This scientific notation becomes really useful when you're using stupid big and stupid small numbers. And nanograms, we're going to see in a minute here. Let's look at nano. Nano here is 1 billionth. So I'm going to make this thing a billion times. I want to discuss it in units that are a billion times smaller, which means my number is going to be a billion times larger. So let's start with our process again. 1.36 times 10 to the 4th grams. And my conversion is going to be 1 times 10 to the minus 9th grams equals 1 nanogram. So I can have 1 nanogram, 1 nanogram over 1 times 10 to the minus 9th grams, or 1 times 10 to the minus 9th grams divided by 1 ng. So I pick my poison here, as it were. Since the grams is here, I need to have grams down here, which puts this one here. 1 times 10 to the minus 9th grams, 1 nanogram. This is going to give me 1.36 times 10 to the 4th grams divided by the number 1 times 10 to the minus 9th. Now, you may or may not remember from your algebra earlier, I can write this as 1.36 times 10 to the 4 minus, because these are division. If they're multiplication, I'd add them. Minus a minus 9. This becomes 1.36 times 10 to the 4th, it would be to the 13th. Now let's double check this. I have 1.36 times 10 to the 4th here, divide by 1. If I go second, this button here where it says EE, I don't know if you can see that, but it's the one right above the 7, but the blue part, because this second button is really a shift. And I say minus, use the key down here to get to that, 9, hit equal, and you can see at 1.36, it's kind of hard to see on the screen, but down here it says times 10, so I have 1.36 times 10 to the 13th nanograms. 1.36 times 10 to the 13th nanograms. And see, like I said, the hard part was going from the 30 to the 13.6. The rest of it, I'm just moving decimals. I'll leave it for you to figure out what milligrams is. The milligram is here. It's 1/1000th. Now for tons, I'll help you out on that one, because you need to know that there are 1,000 kilograms in 1 ton. So we start off with 1,000 kg equals 1 ton. So I can say 1 ton over 1,000 kg, or I can say 1,000 kg per ton. 1 ton per 1,000 kg, 1,000 kg per ton. Saying the same thing 2 different ways, because I then need to look at what do I have for information. Looking at the information here, I could either convert tons into grams and come up with a conversion there, or I can notice that I already have a kilogram. So I can start with 13.6 kg, 1,000 kg here, 1 ton here, equals 13.6 over 1,000. kgs cancel, tons. 13.6 divided by 1,000, and I get 1.36 times 10 to the minus 2 tons, or if you prefer, 0.0136 tons. And that's pretty much it, other than the fact that we can then look at maybe how do we do this for inches. Inches, there are 2.54 centimeters equals 1 inch. So once again, I look at my guy Kevin. He's 30.0 inches tall. I want to put the 1 inch on the bottom, the 2.54 centimeters on the top. That way I can say, okay, 30.0 times 2.54 gives me 76.2 centimeters. If I want to convert this to meters, I realize that there are 100 centimeters per 1 meter. And once again, I can go 76.2 centimeters. And I go 100 centimeters down here, 1 meter up here, and I get 0.762 centimeters. You notice I have 3 digits here because I have 3 digits there. 3 digits. 3 significant figures. From there, you can complete the rest of this, because the first question was centimeters, which we answered. Don't need to know meters per se, but if I want to go to micrometer, if I start with the meter answer, it's a easy. This is supposed to be meters, not centimeters. Or minute. Start with meters, I can go micrometers, decameters, and terameters. Once I have it in meters, a lot easier. So if you have any questions, ask them.